Remember that gas turbine model we built? Today we are pushing it to the limit. We are running a sensitivity analysis to see exactly what happens when we start throwing hydrogen into the mix. Before we crunch the numbers, we need to set the stage. I will show you how to frame the case in HYSYS and lock in our analysis boundaries so that the data makes sense at the end of the day. Once we've set up the case studies, we are going to run the simulations and keep an eye out for any red flags and make sure that all our cases have converged without any hidden errors. Once the simulation is finished, I'll show you exactly how to pull these results into clear view, but most importantly, how to correctly interpret what the results are actually telling us. Now, here is where it gets interesting. We are digging deep into the fine print because this is exactly where it is easy to misinterpret the data and end up totally off track. Before we jump into HYSYS, check this out. Look at the combustion temperature curve. As we add more hydrogen, the temperature goes down. And if you think that's impossible, you are not alone. Hydrogen is meant to be driving this temperature up. So is this model broken, or is there something even deeper happening? And the only way to find out is to open into HYSYS and investigate what could be causing this behavior.
All right. First thing, when we are doing sensitivity analysis, we need to check the main flow sheet. Make sure you see that nice green converged bar at the bottom and your results are still solid. Before we jump into the case study, let's turn off the hydrogen adjuster. Just right click on the icon, scroll down, select ignore unit operation. And why do we do this? Because we are now taking control and handling the hydrogen mass flow ourselves. This will be determined by the steps that we are going to set up in the case study. So next, head over to the case study folder, right click, and start a new case. I'll give it a simple name and call it hydrogen. Now let's pick our independent variables. Just click on the Find Variable button, look for the hydrogen material stream. We want the mass flow rate. Bring it over, hit done, and then boom, there you have it. The 123 kilograms per hour is our starting point. That's the hydrogen mass flow rate from the original model before we run any sensitivity analysis. Alright, now that we've figured out the independent variables, let's chat a little bit more about the dependent ones. These are the parameters that we are really curious about, like how they change when we crank up the hydrogen in the fuel gas. Honestly, I think this is the fun part. If you've been following along with the previous videos, you'll remember that we set up a nice dashboard where we list all these dependent variables. The first one being the turbine inlet temperature, CO2 emissions in kilograms per hour, the hydrogen mole fraction in the fuel gas, the turbine thermal efficiency, the net power produced, and the most important one, which is the percentage CO2 reduction. First off, we need to change the case study from nested to sensitivity. That's very important. Next, let's define our boundaries. We'll start with a completely zero flow, no hydrogen at all, and then gradually increase to 250 kilograms per hour. Let's go with a step size of 10. In that way, we'll end up with about 26 different snapshots of how the turbine responds as the fuel mixture changes. Once we've set up the case study, it's time to run the simulation. When you are ready, just hit the run button. You'll see the yellow status bar moving through the numbers and should only take a few seconds. But keep an eye out because we are waiting for that bar to turn green. If it stays yellow or throws an error on a specific case, don't ignore it. That's usually where the coolest engineering problems are hiding. Once the case study is done running, switch over to the Results tab and check the drop-down list to see if any cases failed before doing anything else. The results will show up in two ways, a huge table and charts. If you want, you can export the results to Excel and make the changes there. But honestly, it is way easier to just check the plots within HYSYS. For now, let's jump over to the Plots tab. On the x-axis, choose hydrogen fraction as the independent variable and check the box to vary the hydrogen mass flow rate. On the y-axis, start with the turbine inlet temperature. You'll see that as the hydrogen level increases, the temperature from the combustion chamber decreases. That's kind of interesting because it's not something you'd normally expect. Feel free to scroll down the other charts like the thermal efficiency, CO2 emission, and the net power produced. You probably noticed that the chart title doesn't update automatically when you change the y-axis. It's a bit of a HYSYS quirk, but as usual, there's always a workaround. To change the chart title, just right-click anywhere on the blue shaded area and click on the graph control. Here you can see the properties of the graph. For example, you can open the title tab and modify the chart title. If you're putting together a detailed report and need to share the full data sheet for the case studies, just right-click anywhere on the background and open up the print case menu. Then you can preview the data sheet, which will show all the inputs and results from the case studies. And there you have it. In just a few steps, you can run a sensitivity analysis in HYSYS and easily extract the results. If you're interested to learn how we develop the base model, click on the link on the screen. And if you are still curious about why the combustion temperature is decreasing, we are about to explore the mass and energy balance of this gas turbine. We'll investigate the combustion characteristics, but as a clue, the temperature decrease is as a result of an assumption that we made in the original model. Remember, we specified the air intake as a constant, meaning we are potentially cooling the flame temperature by putting too much air. To do a detailed investigation, that will deserve its own video. So keep watching and we'll see you on the other side. Cheers for now.